Okay, so the 3.3 practice 2 video solutions. All right, so this time we're actually going to, it wants you to solve this quadratic equation by just solve the equation. Okay, so these are ones where if we can solve this easily, let's do it. It wants to solve by completing the square, the first three. Okay, now, if we don't have to complete the square, well, it tells you to, so do it. But could we have done this more easily? Yeah, we could have. We could have factored the left side using magic numbers. What two numbers multiply to -9 and add to +8 would have been +9 and -1. And so our solutions would have just been x equals -9 or x equals 1. So let's do this by completing the square though. So we get, let's chase the 9 to the other side. So we get x squared plus 8x space equals 9. And then we're going to complete the square. Half of 8 is 4, which means we have to add 16 to both sides to make that happen. So we get x plus 4 quantity squared equals 25 from completing the square. Now all we need to do is just isolate x by reversing order of operations. So the steps to get x by itself would be, first we're going to square root both sides, and then we'll add -4 to both sides. So when I square root both sides, I get x plus 4 equals plus or minus the square root of 25, which is 5. And then if I add -4 to both sides, I'm going to put it in front of the plus or minus. My answers are x equals -4 plus or minus 5. So if I take the plus sign, that gives me x equals -4 plus 5, which is 1. If I take the minus sign, x equals -4 minus 5, which is -9. So my solutions are -9 and 1. Okay, same thing here. So we'll solve by completing the square. So we're going to chase the 2 to the other side. So that gives us x squared minus 7x space equals 2. Half of -7 is -7 halves, which means I add to both sides -7 halves squared, which is 49/4. I square the -7, square the 2. -7 squared is 49, 2 squared is 4. So what am I going to get on this side? Well, if I multiply both the top and the bottom of the 2 over 1 by 4 to get a common denominator, that's going to give me 2 times 4 is 8 plus 49 over my common denominator of 4, which is what? 8 plus 49 is just 57 over 4. And so that gives us the equation x minus 7 halves squared equals 57/4. Okay, so now to isolate the x by reversing order of operations. So first we'll square root both sides to undo the squared. That's going to give us x minus 7 halves equals, when I square root both sides of an equation, I know I've got to add a plus or minus. The square root of 57/4, which is the square root of 57 over the square root of 4. The square root of 4 is just 2. So we get plus or minus the square root of 57 over 2. I'll just add the 7 halves in front of the plus or minus, which gives me x equals 7 halves plus or minus square root of 57 halves. Okay, so my two answers are seven halves plus square root 57 halves and 7 halves minus the square root of 57 halves. Okay, so this one, same kind of thing. Okay, so on this one, we could chase the 12 to the other side, so we get 4x squared minus 8x space equals negative 12. We'll divide both sides through by 4, which gives us x squared minus 2x equals negative 3. Okay, so then completing the square, half of negative 2 is negative 1, which means I'm going to add to both sides negative 1 squared, which is 1, which leaves me with negative 2 on the right side. Okay? So, by the way, the instructions say solve the equation, write exact simplified solutions. If solutions have imaginary parts, include the imaginary unit I in your solutions. Okay, so when I isolate x here, first thing I'm going to do is square root both sides to undo the squared, which gives me x minus 1 equals, plus or minus, of course, but notice I have a square root of negative 2. So the square root of negative 2, remember, is equal to I times the square root of positive 2. Okay? So the last step is just going to be to add 1 to both sides. I'll put it in front of the plus or minus. So my answers are x equals 1 plus or minus I times the square root of 2. And the I can go after the square root, but just you can't put it underneath the square root. So 1 plus square root of 2, and if I want to put it afterwards, that's fine, but make sure the I is outside of the radical. And 1 minus square root of 2 times I. Okay? Okay, next problems have to do with discriminants. I'm actually going to go down and do this third group first. I think that actually makes more sense. So remember, the discriminant is just the part under the radical in the quadratic formula, right? So if I put this one into standard form, I get, if I subtract 4x squared from both sides, we end up with the equation 4x squared minus 8x plus 4 equals 0. So here's a little trick. I could either use the quadratic equation as it's written, I could use that one, or if I want to divide each side through by 4, I can trade this for a simpler quadratic equation, because that's going to give me x squared minus 2x plus 1 equals 0. That's a little better, because now when I plug into the quadratic formula, and let's do that. So remember, let's remind ourselves what the quadratic formula is. So if we have a quadratic equation in standard form, then the quadratic formula just tells us that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember that this is the part under the radical that we call discriminant. And we know that if the discriminant is positive, so there's three things that can happen. If the discriminant is positive, then that means we get two real solutions. If the discriminant is exactly equal to 0, then we get one real solution. And if the discriminant is negative, so it's less than 0, then that's going to give me a negative number under the radical. And so that's going to mean I'm going to get two imaginary solutions, which also means I'm going to get 0 real solutions. Instead, I get two imaginary solutions. So let me do something real quick here. So for our problem, here's the quadratic equation that we're working with. So the discriminant then, for us the value, I guess we need to identify the values of A, B, and C. So for us, A is 1, B is -2, C is 1, and so let's calculate what the discriminant is. So we get B squared is 4 minus 4 times 1 times 1. 4 minus 4 is 0. So that means we've got this case where we get one real solution. Okay, so we choose 0 value, so we get one real solution. Okay, what about this one? So this time, we want the value of the discriminant, B squared minus 4AC. A is 6, B is -10, C is 3. So this gives us -10 squared is 100 minus 4 times 6 times 3. Well, that's going to give it 24 times 3 is less than 100. So all I really care about is that that's going to be a positive value. And if it's a positive value, remember, then that means I'm going to get two real solutions. Okay, last one. What about this? This looks complicated, no big deal. All we're going to do is just put this into standard form. So we'll add 3x squared. I'll add 5x. And I'll add 1 to both sides. And that's going to give me the quadratic equation when I add that stuff up. I'm going to get 0 on the right side. On the left side, I'll get 5x squared plus 8x plus 6. So my values of A, B, and C, A is 5, B is 8, C is 6. So the discriminant, B squared minus 4AC equals 8 squared minus 4 times 5 times 6, which is 64 minus something bigger than 64. So 20 times 6 is 120. I don't even care what it is, I just know it's negative. So the discriminant has a negative value, which means it has two complex solutions with imaginary parts. Okay, so moving on up to this stuff. Okay, what about these? So they give us a graph this time. The discriminant of the quadratic equation in standard form corresponding to the graph has a what value? Well, how would we know? Okay, well, the way we know is because when we when we look at the possible outcomes for the discriminant, they tell us the number of real solutions. Well, real solutions always occur, or always correspond to, and this is the key part, real solutions to the quadratic equation in standard form are always x-intercepts, or sometimes we call them zeros. Okay, so we're just going to look at the graph. So we know, for example, that if the discriminant's positive, then I get two real solutions. That means that the quadratic equation in standard form, if I graphed that parabola, it would have two x-intercepts. If the discriminant is equal to 0, I should only have one x-intercept, and if the discriminant's negative, I'll get no x-intercepts. So in this case, we can see that it just grazes the x-axis in one place, and so it's got one solution. And so it must have a 0 discriminant, because that's what we associate with one real solution, which means it has 0 complex solutions with imaginary parts. So we got one real solution. Okay? By comparison, we can see that this graph, this parabola doesn't cross the x-axis anywhere. It's got 0 x-intercepts, and so it's got 0 real solutions, which means it must have two complex solutions with imaginary parts, which we get from a negative value of the discriminant. So just from the graph, we can see that. And then finally, this parabola's got two x-intercepts, and so that means it's got two real solutions and no imaginary solutions. And the way we get that, remember, is when the discriminant's positive. Okay, the last three problems are just solving using the quadratic formula. So all we're going to do this time is same kinds of problems we did before. Only we're just going to plug them into the quadratic formula. So this time we identify A as being 1, that's the coefficient of x squared, B is 1, C is 5. And so if I plug into the quadratic formula, we get x equals negative b plus or minus the square root of b squared minus 4 times 1 times 5. All divided by 2 times a, or 2 times 1. So that gives us negative 1 plus or minus the square root of 1 minus 4 times 1 times 5 is 20, so 1 minus 20 is negative 19. Because we have a negative sign under the radical, we recognize that that's going to give us an I outside of the radical, and the whole thing is divided by 2. But we're going to split this into two separate parts, because the instructions here tell us that if we get multiple solutions, or if the solutions have imaginary parts, include the imaginary unit. I guess it doesn't tell us to do this explicitly, but it's a good idea. We always want to break up the imaginary part and the real part. So we'll just break this into, I'll split this common denominator into separate denominators. So we get negative 1/2 plus or minus the square root of 19/2 times I. Okay, so there's one solution. Then we have to put in the negative version. Okay, what about this guy? Okay, so this time we could just use A is 5, B is 15, C is 5, but once again, why not just divide each side through by 5? If we do that, the first term is going to become x squared, second term becomes 3x, third term becomes 1, and then 0 divided by 5 is 0. So that makes it a little bit easier. Then A is 1, B is 3, C is 1, and we get x equals negative b, so negative 3, plus or minus the square root of b squared, so 3 squared is 9, minus 4 times 1 times c, which is 1, all divided by 2a is 2. So that gives us x equals negative 3 plus or minus the square root of 9 minus 4 is the square root of 5 all over 2. So those are my two, this time there are no i's, so they're real solutions. So there's one solution. And there's the other solution. Change the plus to a minus. Okay, last one. Okay, so to put this one in standard form, I'll just subtract 5 from both sides. And that's going to give us 2x squared minus 9x plus 9 equals 0. So a is 2, b is negative 9, c is 9, and we get x equals negative b, which is 9, plus or minus the square root of negative 9 squared is 81, minus 4 times a times c, all divided by 2 times 2, a is 2, which is 4. So that gives us 9 plus or minus the square root of 81 minus 72. 8 times 9 is 72 is 9, all over 4, which equals 9 plus or minus the square root of 9 is 3, all over 4. So we'll take those two solutions. If we take the plus sign, then we get x equals 9 plus 3 is 12 divided by 4 is 3. Okay. If we take the minus sign, we get 9 minus 3 is 6 over 4. 6 over 4 reduces to 3 halves. So I get the two solutions, x equals 3 or x equals 3 halves. Okay, and that's it.